There's a saying that differentiation is mechanics, while integration is an art. And we say that because for differentiation, you have a law for everything. You have a law for product, you have a law for quotients, you have a law for when they're summing, when they're being subtracted, you have a law for everything. You have chain rule. But for integration, you don't have a law for everything. For integration, you have to pull this, you have to maneuver that, you have to exploit that. And integrating functions such as sine squared x is no exception. So to figure this out, you're going to be keeping two things in mind. That cos 2x is equal to cos squared x minus sine squared x. And that cos squared x plus sine squared x is equal to 1. Those are the two trigonometric identities that we will be using to solve this integral. So let's go about doing that. Now we know that sine squared x would be equal to 1 minus cos 2x all over 2. So if we are finding the integral of sine squared x with respect to x, then that would in effect be saying that we are finding the integral of 1 minus cos 2x all over 2 with respect to x. And that would give us x over 2 plus sine 2x all over 4 plus c. That is the integral of sine squared x with respect to x. So I wouldn't need to show you how to find the integral of cos squared x, because you would just need to use the same two trigonometric identities. So let's get on to more meatier matters. Let's say that we wanted to find the integral of tan squared x with respect to x. How do you do that? Well, we know that tan squared x would be equal to sec squared x minus 1. The integral of tan squared x with respect to x would be equal to the integral of sec squared x minus 1 with respect to x. Now, when you differentiate tan, you get sec squared. So when you integrate sec squared, you must get tan. And when you integrate 1, you will get x plus c. So the integral of tan squared x with respect to x would be tan x minus x plus c. Now we're going to move on to some sum and product formulas, or rather sum to product formulas. And these formulas help us to integrate expressions that are products of sine and or cos. So we're going to be using this last expression here to solve the following problem. Let's say that we needed to find the integral of cos 4x sine 2x with respect to x. The rule that we saw on the preceding page would require that we say this would be half, let me write that properly, half the integral of sine 6x minus sine 2x, which will give us what? This would be, that should be with respect to x, and that would be half negative cos 6x all over 6 plus cos 2x all over 2 plus c, which upon simplifying should give us cos 2x over 4 minus cos 6x over 12 plus c. That is after simplifying and doing some rearrangement. All in all, we come to see that when it comes to solving a combination of trigonometric functions, it's not as simple as it may seem at face value. We have to use trigonometric identities to turn our complex functions into simple functions so that we're able to integrate them accurately.